All right, so this is the introduction section for the Rook project. So my name is Jared Watts, and I am one of the senior maintainers on the Rook project, and I'm also a founding engineer at a startup company called Upbound that's here in Seattle, and we are hiring. All right, so let's talk about what Rook is. So Rook, we can say that Rook is a cloud-native storage orchestrator. And what that really means is that with Rook, we've taken Kubernetes and then we've extended it with a set of custom types and custom controllers that really have the responsibility of automating a whole bunch of the operations around providing storage for your cluster. So that big long list there of tasks to automate, deploying, bootstrapping, upgrading, scaling, migrating, disaster recovery, all that sort of stuff, that is domain expertise in how to run a storage system that's been put into automation inside the Rook software. So it's also now, it can be thought of as a framework, a general framework for providing storage solutions or integration for storage solutions into Kubernetes. And we'll look at that with a couple examples later on. And also important to note that it's an open source project with the Apache 2.0 license, and it's also hosted by the Cloud Native Computing Foundation. We first were accepted as a CNCF project in January of this year in the sandbox level, and then just in September, I think it was, we graduated to the incubation level. Yeah, I think that was in September. So that was really cool to now see the Rook logo and Rook socks and Rook flags and all this stuff flying over Shanghai and here in Seattle as well. So we are an incubator project in the CNCF now. It feels like a real project. That's definitely thanks to community support for sure. All right, so let's talk about what storage or how it's normally done in Kubernetes. So normally what you'll do is, there's these volume plugins that allow you to bring external storage solutions inside of your Kubernetes cluster. You can have appliances, expensive proprietary appliances, or you can have managed services from the cloud providers like Amazon EBS volumes or Google Persistent Disk. But at the end of the day, what's really going on there is that you're using a volume plugin to connect your container orchestrator, Kubernetes, to these external storage systems that lie outside of the storage of your Kubernetes cluster. So that has a few limitations. One is it's not really portable because that requires that those external services be accessible, be present. If you were to go to a different Kubernetes cluster where you don't have your storage appliance set up, you don't have that storage anymore, right? And it also has a bit of a deployment burden. So somebody has to set up those external solutions and make sure that they're running. And then if you're using cloud provider managed services, that has a possibility to get you into a vendor lock-in situation, but there's some solutions that are starting to address that now, which is nice. So instead of having your storage outside of the Kubernetes cluster, what we decided to do with the Rook project when we started it about 2 years ago is to go ahead and bring that storage into Kubernetes. So Kubernetes is really good at reliability and management, lifecycle management, keeping things alive, health checks, all this stuff. It's got a lot of built-in smarts and built-in primitives that make running complicated applications a little bit easier. And so we did that with storage, basically. So running your storage as containers in Kubernetes is really the kind of what this main solution here that we're talking about today is. So this enables more portability in our applications. And now, why is portability important? So it really comes down for me to the power of choice. So when you have an application that can go run anywhere, you get to choose where you want it to run. You're not locked into running it in one specific environment or one specific place. So you can start making some decisions about cost or the feature set or availability or government compliance, whatever it may be. When your application's portable, then you can start making a choice about where it runs. So basically, you can take your storage wherever Kubernetes goes also, right? And so Kubernetes did a great job at providing these abstractions in the forms of pods and volumes so that an application that requires a block device or a file system can basically run anywhere now. That's awesome. But that's not the only type of storage, right? There's databases, there's buckets, message queues, all sorts of stuff that is not just represented by a volume. So what we need is abstractions for those types of storages too, or types of storage, excuse me. And so that's something that we kind of started to solve in another open source project that we just went public with, I think, a week ago today. So it's still very early, but it's called Crossplane. And there will be some ties into Rook here that we'll be looking into and talking about later, too. But it gets down to portability, being able to run your application as well as its needs for data anywhere. All right, so let's talk about a couple things about how Rook provides these storage services inside of Kubernetes. So a couple of background information here to go over to make sure we all understand here, give a foundation. First is what's called the operator pattern. So I first learned about this, I think it was from CoreOS a few years ago. I think they started evangelizing the operator pattern first off, at least what I heard. And so basically what it does, though, is it takes software and it codifies that domain expertise and these administrative operational actions that a human normally does and puts that into software. So it's kind of a fancy way to say software automation, right? But it basically removes some of that manual intervention, the burden on the human, and puts that into smart software systems. So an operator, really what it does is it sits in a control loop, where there's 3 phases to that. First, it's got to look at your system. It's got to see what is the current state of my system, and then analyze to figure out, okay, the user has said they want the system to be in state X, but I'm seeing the system is actually in state Y. So now I've got to act as that operator, as an automated piece of software. I have to act upon the system to drive it towards from actual state to what the user actually desires, right? And then another important background piece of information here is custom resource definitions. So the CRDs are becoming much more popular now. It's more of a common term than it was a couple of years ago. But basically what CRDs let you do is they let you define your own custom types. And the cool thing about that is that your custom types that you define, they're treated as first-class citizens in the Kubernetes API. So just like a pod or a config map or a stateful set, you create a custom resource definition, and your type now looks the same as any of those inside of kubecontrol. So you can use kubecontrol get storage cluster, and that will give you that same sort of experience you're used to for pods and config maps and other things. All right, so in terms of operators, Rook itself is a collection of operators. So Rook implements that operator pattern for a number of different storage solutions. So we allow the user to define the state that they want to have in their storage cluster. And we've captured that in various abstracted models, such as storage clusters or pools or object storage or a shared file system. Those are new custom resources that the user can use to specify that they want an object store or they want a storage cluster. And then the operator, the set of Rook operators, will look at those custom resources that the user has defined or specified, and then go through that reconciliation loop to make a reality in the actual state a reflection of what the user has declared that they want to have happen. And what's cool about operators is that they get to use the full, they're first-class citizen as well. The Kubernetes API gives applications the power to do all sorts of useful stuff in the Kubernetes. You can spin up services or replica sets, or you can create config maps, all sorts of operations that you can do with the Kubernetes API. The operators can leverage that. So you can put all that together, and then you can start doing interesting things with your storage system. You can start doing stateful upgrades. You can do rebalancing of data around the cluster. You can monitor the health, and if something's going wrong with their storage cluster, the operator can start taking corrective action on it and rectify that situation. So something important to note here, though, is that Rook, these operators for Rook and their storage systems that they manage, they're not on the data path. So they can be offline for minutes at a time, and when you're reading and writing bytes, you're still going directly to and from the underlying storage system that Rook has managed and set up for you. So the operators don't have to be high availability or HA. They can be offline, and you do not lose access to your data reading and writing in the cluster. So here's a little busy slide about the architecture, but one of the important things to note here is that in the middle of the slide is the Kubernetes API. So that's where really everything is focused around here. So on the left side of the slide, we've got kubecontrol, and so you can use that to interact with the Kubernetes API and start using these objects, these custom resources that Rook has defined about storage clusters and pools and object storage and all that. And then in turn, the Rook operators on the right side of the image here are going to be also connected to the Kubernetes API. And they're going to get events that a user has declared a storage cluster that they want or an object store that they want. And in response to that, these Rook operators are going to in turn use the Kubernetes API to create API objects such as daemon sets and config maps and stuff to build that storage cluster from scratch inside of Kubernetes. Another important part here is that we've got on the right side a number of daemons that are running. So for the various storage systems that Rook supports, such as Ceph or CockroachDB or Minio or others, Cassandra is a new one as well. Those daemons that make up that storage system will be deployed out into the cluster in pods and connected to services and stuff by the Rook operators. So you've got the Rook operator running. It's set up your storage cluster with whatever underlying storage system you care about, and those daemons are running, and the Rook operators are managing them. But all this is through the Kubernetes API. So this is just a bit of a visualization here for what it looks like when you're deploying Ceph on your Kubernetes cluster using Rook. So I'm not sure how many people here are familiar with Ceph, but it is, oh sweet, hands already started rolling, I didn't even asking. Awesome. So either you've used Ceph and you've had a good experience with it, or you've used it in Rook, but I'll just keep rolling and smiling and thinking that your experience has been awesome. So basically, Ceph is a distributed storage system that can turn all of your local storage within your cluster into a highly scalable, highly performant, highly reliable distributed storage cluster. One massive pooled together storage, right? And so the experience here we're looking at on the left side of this slide, on the left side of the slide is one of these custom resources we were talking about. So that's a cluster object. That a user creates one of these in YAML and says kubectl create -f and then this file, and then what they get out of that, because the Rook operator is watching for events of on the Ceph cluster object type, and then the user has described how they want that Ceph cluster to look. They want it to use all the nodes in the system. They want it to all devices that start with SD to include those into the storage cluster, and then also deploy BlueStore onto the Ceph cluster. And so on the right, we have a bit of a visualization of the various components of Ceph that the Rook operator spins up and creates pods for and connects and does all that work. So at the end of the day, you take the user's desired state of this cluster that they've described how they want it to be, and the Rook operators, through the software automation and the Kubernetes API, turn that into a running storage cluster. And so Rook doesn't just deal with Ceph anymore. That was our first storage system that we supported in Rook. And it actually just this week in the 0.9 release on, maybe it was the weekend. It's been a busy week. But it was just declared stable. We went V1. So the Ceph support in Rook is now stable. People have been using it in production already. That was actually one of the requirements for graduating the Rook project to the incubation level with the CNCF. But now we're kind of more encouraging that because it is stable. We're saying that the API is now stable. So, but in addition to Ceph, though, it's we have this framework that enables other types of storage systems to integrate themselves into Kubernetes. So the way that the benefits that Rook provides for that is that it provides a normalized way for declaring what type of storage or what resources in the cluster to use to pull into the underlying storage system when you're bootstrapping it and configuring it. To say use this device or this node or patterns for matching or selectors and all sorts of things like that to figure out what storage in the cluster should actually get used to store data. And then writing an operator, it's getting easier and easier with all these other operator projects like the Operator SDK and KubeBuilder. But Rook does a lot of that plumbing for you to set you up with an operator, make sure it can watch the Kubernetes API, do the things that it needs to get your storage running. And a couple of other things here too. So I think this slide is up to date, with the 0.9 release, where now Rook supports Ceph and CockroachDB, Minio, NFS, Cassandra, and Nexenta EdgeFS as well, with some more on the way. We'd love to keep expanding the various storage providers and solutions that Rook can get running and managed and healthy in your Kubernetes cluster. All right, so I guess it's demo time. That's what the slide says. Thought I had other slides, but let's get to demo. All right, so what I'm going to show here, and this slide is not for reading. It's just for me to copy and paste so I don't have to type. But what we're going to do here is we are first going to create the Rook operator. So I just said, create operator.yaml. And what that's going to do is spin up a couple of pods there that contains the Rook operator and also contains another pod to do device discovery, kind of figure out what devices are running on a node and report back to a central place saying, node A's got device SD, these SSD devices and these spinning platter devices. And so the operator can make centralized decisions about where the Ceph cluster should get deployed to. And let's go ahead and actually create the cluster. So, kube control create cluster, get that going, and we will kind of watch some of the progress that's going on here. So the operator sees that we have requested to create a Ceph storage cluster, and then it's going to go through all that work of deploying, bootstrapping, configuring, and deploying a Ceph cluster. So this used to be a number of manual steps that were difficult to follow. You'd have to SSH to each node in the cluster, run those commands, copy this value, go over here, do all these sort of things that now have turned into more of a single command of kube control create cluster please, and the Rook Ceph operator here is taking care of that for you. So as we're watching here, it's spinning up the monitors and getting those into a quorum to establish kind of an identity of the cluster and manage some of the endpoints and making sure that the maps of the cluster are kept up to date. And then we've got some other components running there, the Ceph manager. I think the object storage daemon is about to get running as well. So basically, all the components that make up a complicated distributed storage cluster are being done automatically for us. So that looks about done, I think. And so let's do this too. So what I'm doing here is just a quick kube control of just a get on the Ceph cluster object. And so basically what this is showing is that it's made Ceph cluster to be a first-class citizen object inside of Kubernetes. So you can manipulate it and look at it using kube control, modeling a Ceph cluster. And then let's go ahead and create a storage class and a little toolbox as well. So I can run a command and just look at the health of the Ceph cluster and make sure it's happy. Good. So all of the placement groups inside the Ceph cluster are up and running, and they're active and clean. And the object storage daemon is up. The monitors are talking to each other. So there's two modules here, like an extensibility mechanism for Ceph that are missing, I think because I'm using an older cluster. But basically the cluster, all the data here for reading and writing bytes is clean, ready to go, that we can use the storage cluster. So let's kick off another operation here. And so I want to go ahead and get WordPress running on this machine, or this Kubernetes cluster here. So first, WordPress is a stateful application. So it needs a database in order to store all of its state and store all of its, have a persistent storage place, right? So let's go ahead and create MySQL. And some interesting things are going to happen here as part of that process. So MySQL, needs a volume. It needs some place that it can create its tables and store those on disk, right? So it's up and running. That's great. But a whole lot of things just happened here that I will talk through as well. But let me keep it going here. So we're also going to get WordPress running too. And we should see that go to the running state as well. So basically what we saw here is that the MySQL pod, it needs a persistent volume. It needs somewhere, a block device or a file system, to write all its data to. And so the pod gets scheduled somewhere in the cluster, and it needs a volume. It needs to be able to write its data. So the Kubernetes scheduler or dynamic provisioner system asks Rook to, hey, MySQL says that it needs a volume. Can you please provide one? And so Rook talks to Ceph to provision a virtual volume for it. And then on the same node that MySQL is going to be running on, it will do the operation to attach that virtual device from the cluster as a local device, /dev/rbd0, and then go ahead and mount it and put a file system on it, and then hand it off to the MySQL pod, so that MySQL it doesn't know anything about Ceph and Rook running underneath it. All it knows is that it asked for a file system and it was given a file system. And we're going to see something really cool after we get this up and running too. So yeah, it looks like it's running. And so now let's, what I want to do is just grab the IP address for the, for the WordPress instance. Cool, there's WordPress. It took me out of full screen, which is good, I suppose. So I'm now installing WordPress because it is up and running in a pod, and it's a service that's accessible now. And it has a data volume, and so does MySQL has a data volume. But so something interesting to look at here while WordPress is spinning up is that we did this through a storage class. So a storage class can be thought of as a blueprint for how you would create storage. So when MySQL says, I need storage, it's actually going through this blueprint here, this storage class of saying, OK, well, use the Rook Ceph provisioner to make that happen for you. Put an XFS file system onto that for the MySQL instance and use this storage pool. So that provides a way for the administrator to kind of provide some environmental details and specifics of how they want the storage to run, while the application, separation of concerns here, doesn't have to know any of that stuff and just says, give me a volume. Cool, so WordPress is up, and we'll log in with our 4-character secure password. And let's go ahead and create a post on this WordPress site and do a time check. We are good on time. So hello, Seattle KubeCon. So I'm posting to my WordPress. It's there. We refresh the page. It's still there. But let's get a little crazy. So this command here I'm about to run, you can see that it does a kube-control delete pod. And I'm targeting the MySQL pod. So basically what I'm going to do is kill the MySQL pod. And what's going to happen is that the MySQL pod's going to go down. And now it was holding that volume. It was writing to that volume, and now it needs to relinquish it. So Rook is going to go ahead and step in there. It's going to unmount that file system. It's going to detach or unmap the underlying volume from a local device in the node to a virtual device in the cluster. And then the MySQL pod is going to come up on potentially another node in the cluster. And then on that new node, it's going to go through the same set of steps and operations that it performed in the first place of attaching the virtual device from the cluster to a local device on the node, mounting it, and then this time it will not format it with a new file system because there's already data there, so it's not going to overwrite that. But basically, we have made our MySQL database instance to be very dynamic, very versatile. It's more like a cattle and less like pets, right? So what we should see here now is that once we shot MySQL in the head and we refresh the page, we still have our data. We did not lose our data, even though we completely killed our database. Phew. Post that comment. And we're still reading and writing data, and everything is still functional. So this allows you to manage your clusters and manage your data in a very dynamic way, where the underlying storage fabric of the cluster is what's supporting all of the data and providing persistent volumes to individual applications, and they can move around the cluster and be dynamically scheduled, and things stay happy, which is lovely. All right, so let's go back and look at the slides real quick. Cool, so let's talk about how to get involved in the Rook project. So we, as an open source project, we are always very welcome and grateful to have new contributors. I think we topped 100 different contributors to the project now, which is a very nice milestone to get past, but we are most certainly looking for more. It's definitely a community-driven project. So when people come to the repo, you can just try it out in open issues or open feature requests for things that you want to see. So we listen to the community, and we'll be implementing things to take this project in the way that the community wants to drive it. We also have a Slack. We're super active on Slack. We have a global community now, so we will you can see us on there pretty often at most hours of the day. We also have a conferences channel right now for KubeCon Seattle Live, and Rook_IO is for Twitter, and we have community meetings every other Tuesday. So this is what I believe to be the first Rook session this week. And if you did not get enough Rook, there is 3 more opportunities to get some more. So Travis, in the audience there, is giving a deep dive talk about Rook on Thursday at 11:40 a.m. And then there's a session at the Cloud Native Computing Foundation booth where you can come meet the maintainers of the project and ask questions for, I think we're there for an hour, more informal setup there. Just have a little chat. And then I'm giving another talk on Thursday at 4:30 p.m., the last session of the entire week. So I'd be surprised if anybody shows up to that after this grueling, draining week. But if you do, I'd be happy. And we're going to talk about what it takes to add more storage providers to Rook. Because some of the ones we just added, like Cassandra and NFS and Nexenta, they did a lot of work to do that, and it was some interesting integration. So we're going to have actually if all goes as hopefully planned this week and I get some free time, we'll have a surprise demo there too that nobody's ever seen because I haven't coded it yet. So that will be great if I can get that done. So I think I work really well under pressure, so if I say something is going to happen, then I'm setting myself up that I need to meet that, so it'll happen. All right, and so we have like 5 minutes for questions if anybody wants to. All right, and I have a microphone here, and I think your hand first here. Let me see if I turn this microphone on. And so we'll use this because they're recording it, and we want to be able to, for the playback, to be able to hear the questions.
What is the state of the DM crypt layering on top of Ceph?
Oh, that's a great question. So we just in 0.9 started using the Ceph volume tool, which we were already provisioning some the volumes kind of ourselves in Rook's logic. And so using the Ceph volume tool now that has a lot of more of those advanced scenarios built into there enables us to take advantage of that and start doing that. Encryption and decrypt is one of those things that the Ceph volume tool supports. And Travis, that's possible now with that?
With the 0.9 release, didn't quite get that there. Hoping in the 0.9.1 release, hoping to enable that feature, but we're almost there. Just a little issue found out while we were testing with it for 0.9. Yep.
Well, what are you doing here at KubeCon this week? Get your laptop out, start working.
Hi, I just wanted to ask you, during your demo, when you showed the storage class.yaml, it was applied to the whole cluster, right?
Yes, storage classes are cluster-wide, cluster-scoped resources.
Okay, fine. And imagine that if in your demo, instead of using Minikube, you would have been using a cluster with 2 worker nodes, for example, and if the worker nodes only made available local file system, would it be possible that your MySQL pod would have been running on the second worker node and still being able to mount the local volume that was mounted on the first one? Meaning that can Rook support copying the local volumes that were previously mounted to other worker nodes?
That's a good question. Not something I've really thought about before specifically, but an important thing to remember here is that the storage that's being presented to MySQL is a virtual device that's backed by that entire storage cluster. So whatever the underlying storage, raw storage or file systems or directory, whatever it is that you give to Ceph forms a distributed storage solution that's kind of stitches all that storage together, and then from there surfaces a virtual device for you that gets mapped to a local device that the MySQL can write to. So if MySQL happened to land on the same node, or it's using that same underneath, it's using the same local file system for the backing storage for the cluster, it's still a different device, or it's virtualized so that there shouldn't be any overlap or conflict when it comes back up again. So I think that would work just fine with no conflict. Cool. Oh, I saw a hand over there. Ooh, man, that's bright.
Thanks. 2 quick questions. One is, when you deleted the MySQL pod, how did it know you wanted to, when it recreated it, how did it know you wanted that data or that volume back, as opposed to you actually did want to delete your.
Right. So that goes through the dynamic provisioning workflow, where there's objects that model that in Kubernetes. So you have a persistent volume, you've got a persistent volume claim, and they're bound together. And so there's state that's stored there that says that this device has already been provisioned and it does not need to be formatted again. So Kubernetes won't ask us to format it again.
Okay. So
yeah, it's state that's stored in the Kubernetes API.
You had to have deleted that binding.
Right, and the whole persistent volume underneath as well in order to get a new one that would be formatted again.
Gotcha. And the second question is, if I know I'm using Ceph, the Ceph project has a Helm chart now. So why would I use Rook instead of the Ceph Helm chart?
Yeah, so one of the great things about operators, is that they're an active reconciliation over time. So, you deploy something, you can think of other tools being the same model. So if you use Helm to deploy something up front, or you use like Terraform or something like that to provision, infrastructure, what the model there is, though, is that you are upfront provisioning your resources and then, you just leave it, right? And so operators, they're always sitting in that reconciliation loop. So if the monitor's there, if one of them goes down, Rook is sitting there watching it, while you're asleep and you don't want your pager to go off because your cluster's busted, to see that the monitors are down or something's wrong and take corrective action over time actively, so it monitors and keeps things healthy for you so you can hopefully get some rest. Any other questions or? No problem. I'm gonna do a time check too.
What's the relationship between the layering between, like, if I ran Minio or Cassandra, does it automatically provision some Ceph-y thing, or is that my responsibility to, like, say, okay, Minio, here is your block device or file system to run on top of?
Yeah, that's a great question. And so those storage providers are completely independent. Sort of, I guess. Let me back up. So when you're saying Cassandra or Minio, what you're giving it is a persistent volume claim or a template to say, here's the storage you should use. Maybe that's local, maybe that's
And
Ceph.
assuming you already have a storage class set up, that would come from Ceph.
Exactly, exactly. Yeah, so other types of underlying storage can be the backing storage for some of the higher level storage applications like Cassandra or Minio. All right. Any other questions? I think we got time for one more. Yes? Here you go, here's the mic.
You had mentioned the possibility of having a dedicated cluster for storage, kind of, I think it was on the cross-plane slide. Does Rook provide anything for then exposing those resources, or would you still be on the hook for like ingress and everything?
Oh yeah, so that's a good question. So with the dedicated storage cluster there, the functionality that Rook can provide, is really right now focused on the management of that specific cluster, and then setting up that connectivity or ingress and things you're talking about. That's still an exercise that's left to the admin to do that. Yeah, so Rook doesn't handle that for you, but that kind of points to some of the ways that we want to expand the scope of that project is when you have these scenarios where maybe even you have multiple clusters or multiple clouds, you're in Google, you're in Amazon, being able to also provide automation that sets those up and makes them able to talk to each other and work in a truly effective multi-cloud solution is something that we're very interested in, especially in the cross-plane project. So, all right, I think that's all the time we have. So thank you very much. I appreciate it.